Let's have a look at the 2020 Advent of Code, day 13. I'm going in totally blind. I haven't even read the problem description yet. Let's have a look. Shuttle search. So the ferry, which got lost in the storm, has made it to port. There are no ships. We need to get to the airport. There's a bus. Each bus has an ID number that tells you how often it leaves. Bus schedules are defined on a timestamp that measures the number of minutes since some point. At 0, they all leave. Then they come back and repeat. Okay, so ID 5 goes every 5 minutes, 11 every 11 minutes. Okay. My input has 2 lines. The first line is my estimate of the earliest timestamp I could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. X's don't count. Your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. So we have 9:39. The earliest time is 9, the bus IDs in the service are 7, 13, 59, 31, 19. Around 9:39 it looks like that. So the best one we could catch is at 9:44, catch bus 59. Okay, and we have to wait 5 minutes. What is the ID of the earliest bus you can take to the airport? Blah, blah, blah. All right, let's save my input and have a look. Okay, that's a pretty big number. And we've got all of those. All right. Let's get started. So, okay, I think I know how we can do this. If we start with, actually, let's start with their example, because that might be a bit better. And we can test out our idea. So, instead of reading the input from the file, let's do this. So there's the input. Okay, that looks good. Oops. Actually print it out. Okay, we've got our 2 lines. So we've got 2 lines of the input. The earliest time, we'll call it E, is this. Okay, so we've got our first line and the second line. The second line has all of the buses, so we'll call that the buses, and that's map read on L2, but L2 has to be split on colors L2. Oop, didn't like that. And we'll print out those, and this is just to make sure we're, oops, didn't like that. Oh, of course, we need to ditch the X's. Oops, not equal to X. Okay, so now we've got our earliest departure time and our potential buses. I'm pretty sure we just need to find the bus that has the smallest remainder when we divide by that. So if I go print, no, not print, if I go B, the minimum by comparing the, call it best bus, comparing B goes to E mod B. I think that's right. I can never remember exactly how you do this. No, didn't like that. That's in data.list. And the comparing stuff is in data.org. And it tells me 7. Now, is 7 the best bus? So, I think I've got this wrong, actually. 7 is not the right bus. No, what I've calculated is which bus is closest before. We need which bus is closest after, which is the wrong way around. I have a funny feeling that's just equal to, I have to think about that. Okay, here's the safe way to do it. If we imagine a bus, I want this function to return 0 when we're dead on, otherwise the next one up. So I think we need to calculate, let's think about this. So let's just calculate if we're on bus B and we need the value to be E or greater, that would be equal to, so I'm trying to calculate what's the time that I could catch bus B if I wanted to. And that would be B plus, so it would be E plus B minus 1 mod B. That tells me how much over we would be, right? So if it was F, if you look at say F7 939, oh, that didn't work. I didn't like that at all. Let me think about this a bit further. We can do this the slow way so we don't have to panic too much. We can say if E mod B is 0, then it's exactly E. Otherwise, it's B times otherwise it's E div B. So that's the number of buses we would miss plus E, I think. Let's try that. So catching bus, well, it didn't work out, sorry. Must be B plus E. No, that's worse. Ah, goodness me. B times that. $9.45, that's good. So if we wanted to catch bus 7 at time, but no earlier than 9:39, we'd have to catch it at 9:45. If we wanted to catch bus 13, it would be at 9:49, which looks like what we've got there. And bus 59 would be 9:44, which looks good. So instead of comparing with this incorrect function, we will compare with BE. So that should tell us which bus is the best now. It's telling me it's bus 59. And what we have to calculate is the ID of the bus, which we've now got. So we'll call that best ID. And we need to multiply it by the number of minutes I'll need to wait for that bus. Okay, so I don't particularly want to calculate it again, but maybe I will. So my catching time is the best ID we can do the multiplication. I think we'll just do this again. It's pretty ugly, but we'll do it anyway. There is a nice formula for this that I can't remember. If E mod B is 0, so it's E mod best ID, then it's E. Otherwise, it's best ID times that, times that. That's the catching time, and then our waiting time is the catching time minus... Oh, I've lost the plot. The catching time is, of course, S, best ID E. And our waiting time is our catching time, our catching time minus E. We can print catching time, waiting, make sure that looks sensible. So I catch bus 59 at time 9:44, which means I waited for 5 minutes. And if I not print out, what is it? The bus ID multiplied by the waiting time. I get 295, which is the answer. So now if we do the real input, instead of that one, run the program, 136. Okay. That's right. Let's have a look at part 2. The shuttle company is running a contest. 1 coin for anyone that can find the earliest timestamp. The earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus ID departs at that subsequent minute. I have no idea what that means. For example, suppose you have the same list of bus IDs, and X means there are no constraints on what bus IDs must depart at that time. I still don't understand. This means you're looking for the earliest timestamp called T. I'm looking for the earliest T such that bus 7 departs at T. Bus 13, oh, I see. Bus 13 departs a minute after T. Doesn't matter what happens with the X's at 2 or 3 minutes. Bus 59 departs at 4 minutes after T. There are no requirements. Who cares about the X? 31 departs 6 minutes after T. Bus 19 departs 7 minutes after T. So the earliest T that meets all those conditions. I wonder if just enumerating it is going to work. The only bus departures that matter are the listed bus IDs and their specific offsets from T. The only bus departures that matter is, okay. Those bus IDs can depart at other times and other buses can depart at For example, in this time, because bus ID must depart 7 minutes after the timestamp, because it's that one. 1, 2, 3, 4, 5, 6, 7. Bus ID 7 will also always be departing with bus ID 19 at 7 minutes after T. Right, yep. Okay, and in our example, given that the example is already at 1 million, just enumerating, walking through the times is probably not going to work. Okay. Here are some more examples. However, with so many bus IDs in your list, it's going to be a big number. What is the earliest timestamp such that all of these things happen? If we just have a look at our input again, quite a lot of buses. Well, this is not so trivial, is it? So we're looking for a time T such that 1, 2, 3, 4, 5, 6, so 7 minutes after 13. So we're looking for a T. So we're looking for a T such that T is a multiple of 13. So T is equal to 13 times some K. T is also equal to, or rather T plus 7. I think that was 7, wasn't it? 1, 2, 3, 4, 5, 6, 7. T plus 7 is 37 times K. And we're interested in one that T plus whatever that is, 13, 8, 9, 10, 11, 12, 13. T plus 13 equals 401 times K. And so on for all of the buses. For all of the buses. So I wonder, we can also say that T is 13 times K. T is equal to 37 times K minus 7. Equivalently, we can say, I mean, these are not all the same K, by the way. Because we can equivalently say 37 times K 2 plus 30 if we want. And T equals 401 times K3 minus 13 or plus whatever that is, 380 something, 388. So we're looking for that sort of T. Surely not a coincidence that all these numbers look like they're primes. Now, how do we find such a t? I wonder if we can just see what happens. If we try combining some of these. If I have this and this together, then I know that 13 times k, we'll call that one k, equals 37 times k, or j. No, it's 7. Does that tell us anything about what k and j might be? Not really. Because they seem to be relatively prime, like 13 and 37. If they miss each other, you've got to wait probably 13 times 37 minutes again. Here's a way to look at it, that if they miss each other, right? So if you're at some t, imagine you're at some t, which is a multiple of 13. And then you look 7 minutes later, you look at t plus 7, and you say, what is t plus 7 mod 37? And if the answer is 0, then the two buses have coincided. But if the answer is not 0, then they haven't coincided, and the answer you get tells you how far off you are. I've understood it right. Like if you look at, I don't know, 13 times, it's 13 times 3, and you look at 39, 7, which is 46, mod 37, then we're off by 9 minutes. And if we then add, no, it doesn't work. I wonder if we can just look at the pairs. Because if you look at all the numbers where this is going to be satisfied, right? Let's look at all the t's such that t plus 7. I'm just going to see what happens if I just try to satisfy the first two buses. So t has to be drawn from multiples of 13. So k, t, 0, t equals 13 times k, and let's check that t plus 7 mod 37 is 0. And the first 100 of those, I'm guessing there's a constant thingy in between them all. Are they all 13 times 37 apart? Yes, they're all 481 apart. There's a constant difference between all of them. And I have a feeling all of my numbers are the same because they're all relatively prime. If we look at our input again, 401, 17, 19. I think most of these are prime. I think all the little ones certainly are. Just check, I suppose, if we want to make sure. Let's find all the factors of n. To n such that n mod k equals 0. Oops, didn't like that. Yeah, that's right. And 101 is prime. What was the other thing? 613. 613. So it looks like we only have to check numbers. I think we just have to multiply them all together. and check only those. So if we find the first one, but if I multiply all of those together, like even if I take all these numbers and multiply them together, oops, didn't know. Take these numbers, get rid of the x's, get the product of them, calm down. That is a big number, as was warned. That on its own is not very useful. So let's think about this. So as you see in the picture, they're all spaced out like this, but there's a pattern between them. Like this one went from, it goes from 1. If you look at the relative offset of this one to this one, it goes from there to there. And it's going to repeat. So it's like 1, and then they're at the same time, and then the next one will be a minute before, because you've got 7. Because you've got the multiples of 7, and you've got the multiples of 13, but you have to just look at them. I don't think we can just walk through the numbers here. No, it's way too big. Well, this is not as easy as the other ones this year. Okay, hang on. So I haven't calculated this. These are the only possible candidates. Right, and then the question is, what are the, so this should be the intercept, like if you were to calculate what are the, this is the intersection of all of the bus 13 and bus 37. This is the times at which they coincide, because this is a multiple of 13 and this plus 7 is a multiple of 37. Right, so those, we've already narrowed it down. We only have to check every 500th one. If I then combined that list with the next bus, where are my buses again? So if we look at the 401, so if we start writing this down, this is a bit not the way I would like to do it, but it's okay. So the candidates are this. All the times such that we're a multiple of 13, but we also match 37. I've mucked this up. Let's just go over this. Let's just, so our buses whoops, this, which is to say, let's just replace all the x's with zeros, and we'll say zip this with 0, and then filter, we keep only the ones where it's not 0. Okay, so that should give us our buses. There we go, and their required offsets. I mean, it seems like the formula we had should be really helpful. Like, we need a t that is 13 times a, and it's also equal to 37 times b minus 7. And it's also equal to, what's the next one? 401 times c plus minus 13. Just wonder, can I figure out some relationship here between A and B? If 13a equals 37b minus 7, then what's the relationship between A and B? What if I multiply 13 times 37? I multiply both sides by 37. No, that's not going to work. Maybe it will. 481a equals 481. Oh, that's not correct. It's going to give me 37 squared. 37 times 37b minus 259. What good is that? I don't think this is very useful. I'm sure I'm missing something very critical there. Anyway, back to my buses. So I have my buses. 13. I feel like there's some way of saying they missed by this much, therefore we must jump ahead this many buses. Because if you look at the multiples of 13, right? Right, and then if you say for each of those, take I mod, or I plus 7, really, mod 37. This is going to cycle, right? It should, I don't know how far it needs to go, but I'm sure this will repeat over and over again. Yeah, there it is, 720, 33, 72. So it repeats every 37, of course. Which means where the zeros are, it feels like you just need to find the first 0, and then you can jump ahead, whatever it is, 13 times 37. Or, you can bump k up. K can jump up by 37s. So given that the first 0 is there, what does that mean? So k was 0, 1, 2, 3, 4, 5, 6, 7, 8. So k was 38. 13 times 8 was our first hit. That was our first hit. And that means, yeah, like we found out before, that we know the next hit will be 104 times 17 times 37, which is at 733. Is that what we saw before when we did? No, because it's not 17 times 37. It's 13. 585. That is our next hit. So those are the only hits we need to worry about. And then how do we extend this to the next number? Because if we did the same thing, for the next one, what's the next number? 401. Because exactly the same thing is going to happen. But do I need to look at 13 and 401 or 37 and 401? Or do I need to look at 585? Okay, so one thing that's true is that all of these bus IDs are primes, which means they're all relatively prime. But even when I multiply them together, when I multiply 13 times 37 together and get 481, of course, they're still relatively prime because that's composed of primes that are different from these ones. So I feel like you can even figure this out. You wouldn't even need to count this. What was it? It was 8, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. I feel like you can even work that out without having to iterate through them. Because this is going 13, 13. Let me see if we can figure that out. So the question is, if I'm here, how many jumps do I need to make before this hits 0? Every jump is jumping me 13. Well, I wish this had been one of the easier problems today. I wonder if it works the other way around. Suppose I'd done it the other way around. So instead of going with multiples of 36, I'd done it this way and swapped this around. And maybe I am that. Subtract 7. That. And then we'll look for 13 instead. Oops, didn't like that. Maybe we'll do that. There we go. So now we're getting the same, we're getting again a repeated pattern, but it's only 13 long, which is good. Because I think that means we can just multiply them together, take the shorter one, find out where it's 0. I think this will work, all right? I think this might work. So let's have another go. So let's see. Let's see. I'm going to fold over these bus things. So each bus is defined by an offset and the bus ID, call it B. And what we want to compute is what? is that magic number, that 480, is it the 481? Because actually, maybe that's what we've got to do, right? You take the first two and you align them, right? And you say, okay, when are all the times when the first two buses align? Yes. That's what it is. I think I know what to do now. I think finally it has dawned on me. Yeah, I think I know what to do. So imagine you've got your first bus, right? Yeah, I think I know what to do. Fold out. I've got an offset and a bus, and I've got an offset and a bus, and I've got current. What am I accumulating over? The current earliest time that would have worked for all the previous buses. Let's do that. I'm going to fold that, and I'm going to fold over the head of the buses. That's pretty ugly, but it'll. Sorry, not the head of the buses. We'll cheat a bit because we know what the first bus is. First bus is 13. So it's 0, right? And we need a repeat factor. Yeah, 0, 13. Of course, it's the first bus anyway. So what we've got here is we've got, first of all, we've got this the wrong way around, haven't we? Yeah. So what we need to do, we need to keep track of what is the earliest time that satisfied all the other buses, and what is their sequencing number. S for skip. Okay. And what we're going to do is I'm just going to change this to this, to that. I'll put that back. Put that back. That's losing my mind. That's it. Just do that. We'll do that. Yeah, we'll figure that out. Really? Oh yeah, because integer, Now, no, you're still unhappy. Really? I'm just doing it this way because I want to be able to test it just on the first couple. So if I go take 2 buses, I'm going to complain that I haven't actually done the work. But I think what we need to do, so imagine in this case, in our first case, T is 0, S is 13, and O and B are the new bus. So O is 7 and B is 37. So we just need to skip by multiples of the new bus, 37 in this case. No, by the old bus. Because what I want to do is go 13 until I hit the one that works. Is that right? Yeah, I think I want to just jump forward. Yeah, yep. So let's just, instead of thinking too hard, let's see if we can just try and write down what comes to mind. So we're going to loop. We're going to start. We're going to start at T. Yes, we're going to start at T. So we're currently at T prime, right? And we say if T prime mod, or if t is really t prime minus offset mod b is 0, then we're good. We've found nirvana, right? And where we need to be, so t prime is the first time that satisfies all our old buses and this new bus. Now I think I've got this plus the wrong way around. Yeah, because t prime plus O needs to be that. And then, so we go on our next step to t prime b times s. However, if we didn't quite make it, then we want to go we want to just increment by the next one. So it should be just loop t prime plus s in loop t. Okay, let's give this a whirl. So what has that told us? It's told us that the first hit is at time 104 and we need to skip ahead by 481. That's perfect. I'm just going to test this on the short one. Let's do this. So this, oops, all that into there. Well, here's lots of examples. Oh, that's nice. Let's do the big one though. The original example. Okay, so these are zeros. Okay, that's 2, 3, 4. That's so good. Do them all. And it gave me the answer at time 1068781, and that's the skip factor that we don't need. And the answer is 1068741. Well, that's very promising, isn't it? Because it means, with any luck, you can do that and get the answer. And God willing, we get the right answer. 1 gold star closer to saving our vacation. Well, that was pretty painful, but fun in the end. Thank you for watching.